In this video, we're going to find the GCF of two given numbers using three different methods. Crazy. Here we go. Oh, look at those. Oh, that was cute. Our first method is called the prime factorization method. Basically, what happens is you factor 420 and 600 into primes. One way to do that is using a factor tree. For instance, 420 is 2 times 210, and 210 is 10 times 21. 10 is 2 times 5, and 21 is 3 times 7. So at the end of the branches, we have two 2's, 1 3, 1 5, and 1 7. So putting that all together, 420 is the same thing as 2 squared times 3 times 5 times 7. Whereas 600, which I'm going to write right here, is, for instance, 6 times 100. 6 is 2 and 3. 100, 425, for instance. 4 is 2 times 2, and 5 times 5 makes 25. Now, as far as how you break it down, doesn't matter, but you have to end on primes, and no matter how you break it down, you should get the same prime factorization. So 600, notice for 600 we have 3 2's, so that'll give us a 2 cubed, 1 3, and 2 5's. So for the method of finding the GCF using the prime factorization, what happens is, and this gets a little wordy, you only look at the primes that are common to both factorizations. Notice both factorizations both have a 2, a 3, and a 5 in common. There is no 7 in 600, so we ignore the 7. And I'll explain this a different way in a second if you don't like this first round. Basically what happens is, after you write down the common primes, you look at the exponents. And for the GCF, you take the smaller exponent. So notice for 420, we have a 2 squared, and for 600, we have a 2 cubed. So of the two exponents, which is smaller, 2 or 3, you would say 2. So we're going to write 2 squared in the GCF. Notice for the 3's, they're technically both 3 to the firsts. And if you want, I'll write that in. So technically it does not matter which one you pick, because they both are the same value. So in the GCF, I'm going to write 3 to the first. For 5, we technically have 5 to the first and 5 squared. The one that's the smallest is the 5 to the first. And again, we don't talk about the 7 because it's not common to both. So the GCF is the product of the common primes raised to the lowest exponent that appears in any factorization. So for us, we'll have 2 squared times 3 times 5, which is 60. So the GCF is 60. Now another way to say this, instead of saying the primes that are common to both, you could just realize this is really 7 to the 0 here, because 7 to the 0 is 1. So technically, you could still just say take the lowest exponent overall for each prime, and you'll still be okay, because which one is smaller? 7 to the 0, which is just 1. So we don't actually add a 7 to the GCF. Thinking of it that way is actually going to be better, because in the LCM, as it turns out, you take the larger exponent. So that's the prime factorization method. The second method is the dividing by primes method. We're going to write the 420 next to the 600, and apparently I went green. I hope that's okay. And what we're going to do is we're going to divide out common primes and make sure you pick primes. For instance, notice both numbers are even, so we'll divide them both by 2. Now you might be like, hey Mike. Hey, by the way, my name is Mike. I don't know if you figured that out. How do I know what primes to pick? Well, you want to watch the divisibility test video because I talk about how to look at a number and know what primes will work. So there is 2, and notice they're still even, so we can use 2 again. So dividing by 2 one more time, I get 105 and 150. Well, notice they're not even anymore. 105 is not even, so we can't use 2 anymore. So we can try 3. 3 is going to work. This will be 35 and 50. 3 is no longer going to work, so let's try 5, which we know will work because it ends with a 5 and a 0. Here we get 7 and 10. And now notice we're left with 2 numbers that are, you might know, relatively prime, meaning their GCF is 1. So in the process of dividing by primes, you keep dividing out all the possible primes you can, and you stop when you have numbers that are relatively prime. As far as what the answer is, the product of these numbers that you pulled out over here is the GCF. So notice our GCF is 2 times 2 times 3 times 5. Impress your friends, because for any 2 numbers, the GCF is unique. So it's going to be 60. And guess what? When we do our third method, can you know what the GCF is? It's going to be 60. So that's the second method, dividing by primes. The last method is probably one of the oldest. It is the Euclidean Algorithm by this Greek guy named John Euclid. Look it up. Okay, I lied. His name's not really John Euclid. So basically in the Euclidean algorithm, you take your smaller number, in this case 420, and divide it into your larger number. Notice this goes in once. And after we subtract, we get a remainder of 180. And then you take this remainder and you divide it into the previous divisor, which was 420. Notice this happens twice. 2 times 180 is 360. Subtract, we get 60. You repeat this process until you get a remainder of 0. So we're going to take 60, the previous remainder, and divide it into 180, the previous divisor. Notice this goes evenly with a remainder of 0. Your last non-zero remainder, or you can also say your last divisor, because they're both 60, is your GCF. Anytime you hear the word algorithm, that just means there's a step approach. That's all. So again, you take your smaller number into your bigger number, divide out as many times as you can, take that remainder into your previous divisor, divide, wash, rinse, repeat, and you're done when you get a remainder of 0. Your last divisor is your GCF. So those are your 3 ways of finding the GCF.